very good morning, good afternoon, good evening to all the participants, students for this NPTEL MOOC course, the title of which is Application of Forecasting, Regression and Time Series Models. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, as all of you are aware, there are three main topics under this 30 hours 60 lectures course spread over 12 weeks. The first topic is forecasting, second one is regression and third one is time series analysis. So, we are doing the third last part, which is time series analysis, and this is week 12, which is the last week starting, and we are going to start lecture number 56. What is the coverage? Coverage will be auto-regressive process, the concept of stationarity and causality. Now, an auto-regressive model is basically the foundation for ARIMA model. ARIMA model, we have mentioned some important points, the characteristics, and based on the three parameters, which is P, D and Q, you can basically assign the specific characteristics, and that has been mentioned in one of the slides in the last lecture, which was the last lecture for the 11th week. So, ARP, so P is basically the parameter. So, if you remember in the ARIMA, the first parameter P was basically related to the auto-regressive concept, and the concept of Q was related to the moving average. We will come to that later. So, then ARP which basically would be form of this, and we will highlight and discuss the important points. So, XT is basically the so called series, and it consists of two set of terms. One is the summation, and the summation is terms is based on the fact that what is to what level of parameter, to what state or stages you are going. So, the parameters basically are given by phi 1 to phi p depending on p as the parameter, and it is basically auto regressed based on the time series or the series which you have, based on the fact that you are taking one point at a time going into the future. So, if you see this summation, considering p is the parameter which is auto-regressive model being modeled based on p time periods. So, you will have phi 1 into x t minus 1, that means, just the last time period. Then you will have phi 2 into x t minus 2 next to next in the past, sorry, not in the future, in the past, and you will basically sum them up plus an error term which basically is the white noise. Now, the time period can be taken as 0 plus minus 1 plus minus 2, considering that I am considering both the past and the present. But obviously, when you are trying to predict or forecast for the future, you will take the time periods as plus 1, plus 2, plus 3. That means, considering that you are moving one period at a time into the future. So, here epsilon t is the white noise, and if you know, the white noise basically has the properties where the expected value is 0 and the corresponding variance is sigma square. So, here phi 1 to phi p are the fixed non-random parameters. The expected value for this auto-regressive model is 0 for all t, else expected value will exist. So, in case if we have the equation for the auto-regressive process with parameter p is this, I will just write it down with a different color. So, it is easily visible to all of you. So, I will use again the say for example, the dark blue color. So, here x t, which is already denoted, that will be equal to c, a constant. So, this constant would come into place when you are trying to find out the expected value of the series, and summation, I am not writing the summation, obviously it will be j is equal to 1 to p, you have phi j x t minus j plus epsilon t. Epsilon t, as you know, is the white noise with 0 sigma square, as already discussed. So, here is the last point, expected value exists if a constant term is added, and we have seen that in the writing, and we will see that soon when we come to the final results. Now, using the backshift operator, this backshift operator B, it was mentioned in the 11th week, but I did not go into the details. I will discuss the details right now. So, using the backshift operator B, where the terms are given as B k x t is equal to x t minus k, which means that as you go one period at a time in the past, the operator would basically give you the relationship between x t and x t minus 1. Then the operator, when it becomes b square, depending on k is equal to 2, it will give you the relationship between x t and x t minus 2, and so on and so forth, considering that you are going back into the past and trying to consider k number of terms for the time series, based on which you are trying to model the auto-regressive process with parameter p. So, B is the backshift operator and given by this equation, where I am putting a tick mark, b to the power k. So, obviously, it will become b to the power 1 when k is 1, b square when k is 2, which I just mentioned. And this concept is basically given by this function, because that will dictate how the phi's are being generated and how it is being written. So, it is basically a function of phi, where the relationship is given by the backshift operator B, and that would basically give you the error, based on which you will try to model and find out the auto-regressive process. So, if I write down the whole term considering the backshift operator and considering p is the parameter, the final equation for this auto-regressive model becomes, I am marking in blue, is this. So, there are two terms on the left hand side. Number 1, which is in the bracket, is basically known as the auto-regressive operator of order p, depending on it operates on the time series x t and is able to give you the relationship between the time series and the error. So, here as it is mentioned in the second bullet point, the term 1 minus phi 1 b minus phi 2 b square. So, that as become k changes, here you will basically have the last term is phi suffix p, b to the power p is the autoregressive of order p. Now, if I go into the Australian electricity data production, I will only give you the results. So, here are the, let me go back to the this is in the Excel sheet which I shared in the last set of classes, and I mentioned that as we have done for the forecasting one, we will share the slides along with the Excel sheet for time series. It has been done for regression models, we have also done for the forecasting models, and we will do it for this one once the 12th lecture is over, because there I have added many sets of data in this Excel sheet. So, if I consider the electricity production, this is the time series, it has got 216 the data points. Now, very interestingly, if you see, let me give you the details. We will give you the details from this time series as well as when we run the AR model. The results what we get there, which we just did in MATLAB. I am not going to go in the coding part, there is no coding, you just use the library functions. the results which we get in the MATLAB runs, there is one similarity based on the fact that what result we will get from the Excel sheet. So, if I find out the mean, wait, so average, sorry, my mistake. The average comes out to be 10,440. I will highlight it. So, I will highlight the mean value and let me consider variance also. So, in Excel you have variance dot p, variance dot s, basically that signifies the variance of the population or the variance of the sample, and if the sample is very large, here 200 and plus 200 is quite a significant sample. So, as the sample increases, there the corresponding variance of the samples as you keep taking slowly becomes equal to the concept of the population variance, and this is the concept which we all know is prevalent and very important to understand when we consider the concept of unbiasedness, which is with respect to the expected value of the sample in the long run, and the concept of consistency, which is related to the concept of variability. So, variance dot p, I am considering that as a population. I find out the variance as given as 53733.27. So, I will mark it with a different color, I mark it orange and make it bold. So, now with these two results in front of us, especially the mean value, let us go back to the PPT slides. So, if I consider the Australian electricity production, which is from January 1977 to December 1994, considering P as 1, obviously you can change P, the parameter for the AR model, but I have only taken P as 1. So, there the important facts is phi 1 comes out to be about 0.964, I am only reading till 3 places of decimal with a p value of 1 as I mentioned, and this value of C which you get is the constant which should be added. And if you remember in the last slide I mentioned that considering that parameter fixed value C is added as a constant, your mean value can be found out accordingly. So, if I add that value of C, the C value is 400, I am not reading the decimal place after that, is 400.53. The expected value comes out to be this, that is for the auto-regressive process. Do not get confused with the general average value which we just found, it is 10,440. So, and the variance comes out to be 3,62,192, and obviously you may be asking that the value for the variance is very large. Yes, it is, because if we consider for the electricity production, all the values are in the tune of about 13,000, 14,000, so on and so forth. So, obviously, the variability would be there. So, if I just to make a note, if I consider the line diagram, here the average value is increasing and C is the constant. So, based on that we are trying to find out, and if I consider normal distribution as such, this is just a rudimentary way of trying to draw. So, the mean value is increasing, and very interestingly, even though I am keeping it very simple, the variability is not changing, only the trend is changing. So, again phi 1 is 0.964, C value given for a p value as 1, expected value given, variance given. Now, for the case when you have only phi 1, so in that case, and we are considering phi as 1 only, numeric value of 1. In that other case, it was 0.94. That means, is basically the weightages you are going to give to the past data of 1 unit down the line in the past. So, if x t is equal to phi into x t minus 1 with an error term is basically a random process, and these concepts had been mentioned as a bullet point in one of the slides in the last lecture, which was the 55th lecture, the last lecture of 11th week. So, with considering x t is equal to phi x t minus 1 with an error term is a random walk under the stochastic process, and for phi is equal to 1, it is basically the process is non-stationary, and the non-stationary concept of expected value and variance we have already discussed. We can express the AR process as this also, depending on the concept of how we are taking the phi terms. This is just a other way of trying to denote, and as if mod of phi is less than 1 and k tends to infinity, then interestingly the first term which you have, it can be made as 0, and the next set of summation terms would basically give you the stationary concept for the AR1 process. And also the covariance, if I consider, depending on the lags, if you remember lags has been denoted by h, then covariance of x t and x t plus h depending on the lags is given by this sigma square. So, remember sigma square is the variance of the white noise, and we have mentioned time and again the white noise has an expected value of 0 and a variance of sigma square. So, based on that, if I find out the covariance of the time series, that value comes out to be sigma square into this term which is in the curly brackets, and it only depends on h. So, based on these properties that the as n tends to infinity, x t can be expressed as a stationary AR1 process and the covariance is only dependent on time, we can say is a stationary AR1 process. So, based on non-stationary with the condition that mod of phi is less than 1 and considering k can be extended to infinity in the theoretical sense, you can have the AR1 stationary process accordingly. And here as I mentioned, sigma square is the variance of the white noise. Now, if I, which I have just mentioned a few minutes back, if the AR auto-regressive process with parameter p has that c as a value, then is stationary. If it is stationary, in that case the expected value is given by the term c divided by 1 minus the summation of all these parameters from phi 1 to phi p, and this is constant. So, considering the c is a constant, phi 1 to phi p have been found out, you can say the expected value is also constant and is a stationary process. If in a stationary process we need to find out the variance, you can use the yule-walker equations. I am not going to go into the details of mathematical part, because it has been mentioned as we progressed with the course and from the day we started, it is more of necessary fundamental equations and how they are used. In forecasting, I have tried to keep it as minimal as possible, in regression also as minimal as possible. Obviously, there were some formulas given, theorem given, they were just to motivate that how you can get the results considering different type of combinations of balanced loss function. In time series, interestingly, the amount of equations is a bit more than regression model and forecasting model. So, please bear with me as I discuss. So, we can use the yule-walker equations to find out the variance for the stationarity conditions, given the conditions are true, and the expected value is given as denoted in bullet point 2. C, remember C is a constant, and in the equation which we initially considered, C was considered as 0. Now, for the case when we are going to consider the concept of causality. So, causality and stationarity would have a one-to-one significance. So, the series considering the AR process, and we are not considering the constant C here. So, if it is causal, it can be expressed as that equation here, and remember here we have considered technically the k value tending to infinity as we just did in the last slide, but with an additional condition that the mod of any of these phi's which we get are always less than equal to infinity. So, in that case the concept of causality will hold true. This basically comes from the concept of any series expansion or the concept of limiting concept of this series depending on the properties of the random variable or the series properties which you are considering. So, as I mentioned, causality would imply stationarity, hence the covariance which we considered can also be expressed in terms of the phi. Here there we are considered sigma square, and in the last slide sigma square was basically the white noise variance, and we found out that is only dependent on h, not from where you are starting. And here we also we are expressing with as a function of sigma square into the summation of phi j and j plus h, h is again the lag. Now, for the Arima process, if you remember, we had considered a part with related to auto-regression for which the parameter was p, and the other third part we are considering the moving average with the parameter of q. So, now we will consider the moving average. So, we are considering separately, we have already done them in combined way, now we are considering separately to go into more depth and also understand it. So, the moving average with the parameter q is of this form, where x t the time series which you have, this is an error term, and plus the parameters which is theta 1 to theta q, because q is the parameter, multiplied by the error terms in the past going one step at a time. So, if it is theta 1 into epsilon t minus 1, theta 2 into epsilon t minus 2 till the parameter value of q has been defined. Here also epsilon is the epsilon t is the white noise, t values are 0 plus minus 1, and obviously, if you are going to proceed in the future, the values of t will be taken as plus 1, plus 2, plus 3. So, t is basically the time frame which you are considering. Here theta 1 to theta q are fixed, non-random, expected value is 0 if mean is 0, if it means the mean is 0 for all t, and obviously, if you consider that part which is there, if there is a constant, then expected value will exist if a constant term is added, in the same way as we had considered the ARP process auto-regressive with parameter p. So, using again the backshift operator in the same sense, only remember in the case of auto-regression and in the case of moving average, we are taking the parameters in the first case as phi, in the second case as theta, and the nomenclature has been done in such a way that in the auto-regressive process the parameters are subtracted, and in this moving average process they are added. So, this is the convention we are trying to follow using backshift operator, where again the same concept. Here you have beta b to the power k, b is the backshift operator, k means how many number of terms you will go in the back, b to the power k, x t is equal to x t minus 1. So, b is 1, k is 1, it will be b into x t is equal to x t minus 1, b square means b square into x t is equal to x t minus 2, and so on and so forth. So, if I write x t in this term as we had written for the case in the similar form for the auto-regressive process, the term in the curved bracket is basically the moving average operator of order q. So, P and Q, which I am mentioning time and again, are the orders or the parameters which you consider. And if I consider the Australian electricity production data considering Q is equal to 1, now you see the interesting part. So, theta 1 is equal to given as 0.78903, Q is equal to 1 and C is 10,440. Now, if I and the value of variance is given as 5,37,000, no, it is basically 53,73,330. Now, let us go back to the data set. Now, here is interesting. If you remember, the yellow part of the mean and the variance we have done, and I mentioned that we will be coming back. Now, check here. If I check the value of C, the constant, it is 10440, and here you see 10440. If I see the variance 5373327, again 5373327, it is basically the values, if I do it more carefully, and but the variance and the C values are same. So, the concept of moving average, what we considered for Q is equal to 1, and the simple average which I showed using the Excel sheet are matching. So, it gives us lot of confidence in the way that for the value of Q is equal to 1, the concept of moving average gives the same answer. But obviously, as if I change Q is equal to 2, the operator 2, it would not be same, because in that case the time series would be dependent on t minus 1 and t minus 2 with parameters theta 1 and theta 2, which need to be found and then need to be utilized to find out the moving average values. Now, the reason why we considered AR process and the moving average is because the ARIMA process is a conglomeration of that thing. I am mentioning time and again, please excuse me, but that would basically clear all the doubt. Now, the question may come up that can we do the similar things for the other processes, time series? Answer is yes. So, before I discuss this slide number 67, let me go back to the Excel sheet. So, I will delete this, because as I said, the data set would all be there in the Excel sheet. So, which you can use, and as I am discussing many types of outputs and the graphs. So, specifically for the time series, I am not saving the graphs and the outputs in the pictorial format, only the data set, raw actual clean data set is there, and obviously, the URL is there, you can go into details and understand that. If I consider the passengers, the graphs I am repeating, but just for it clears many of the doubts as we proceed. So, if I consider for Frankfurt the arrival, departures and transit, if I plot the line diagram, and this time period, even though x basically mentions the reading number, remember that was the time when the COVID happened, and I had mentioned that when we were discussing this data before. So, if I come back to the mean, variance, this I will mark with yellow, this I will mark with orange, this I will mark with yellow. So, the mean values and the variance I am saving, I am not deleting them. So, I make it bold. Now, let me put it. So, average, and if I find out the variance, wait, am I doing it right? Let me check. var dot p, yes, I am doing it right. var dot p, yes, I have to using the small one, not the capital. So, this is the variance. So, if you plot the data using the moving average concept, depending on the operator or the value of q as 1, the mean value comes out to be 44,98,728. Obviously, you may think the high values are very high, but do remember the input output data, the data which you have is quite large for Frankfurt total number of passengers, and this is given for per month, and the variability is here. So, if you plot the diagram which is there and you basically do the moving average concept, the answers would be accordingly calculated. So, with this I will end this 56th lecture, which is the first lecture for 12th week, and continue discussing more about time series models and some rudimentary and important data set and their results accordingly. Thank you very much and have a nice day.